Hi, Firefighter Live 2023. I'm Brent Brooks from Toronto, Canada. HighRise Firefighting, and my presentation is on tactical to practical. As far as who I am, I'm an acting district chief with Toronto Fire for now 29 years. I've been a firefighter for 31 years, and my present assignment right now is the HighRise operations for our city in conjunction with the incident management system. I'm also a researcher. I joined the Council of Tall Buildings, which is based out of Chicago, where I get to ask designers, engineers, and architects how to fight fires in their building. I'm also a member of a T70 group committee out of London, England, and we share information as well. I am a researcher. My goal is to get out there and find the big picture, the best known practices, and more importantly, get feedback to figure out professional standards. And it is a true hobby of mine. I do it at donated time. As far as our trucks goes, we have 2 dedicated HighRise units in the city of Toronto. They run 24 hours a day. They're staffed with 4. They're busy. They're very busy, but they have all the equipment and the tactics for HighRise firefighting. The pride of our fleet right now is this 230-foot tower or 70-meter tower. If anyone asks you, yes, Canada makes the clouds and we send them overseas with this giant Bronto. You might want to fact check that. As far as what our city goes, believe it or not, we have over 10 million trees that we have planted. The CN Tower is the largest freestanding structure in the Western Hemisphere. Yonge Street is still one of the largest streets in the world. Believe it or not, we have North America's only castle. The Toronto Zoo is the largest zoo, one of the largest zoos in the world. We have the largest underground shopping complex in the world, thanks to our Canadian winners. We have the largest library-based system in the world, and Toronto Islands are the largest urban car-free community in North America, and Caribana, which I know they've changed the name of it, but it is the North America's largest street festival. So great city that we live in, backed by a great fire department. We have 85 stations, 3,200 members, 3,200 HighRise, over 1,000 skyscrapers, and then 6,000 close to it anyways of low-rise buildings. As far as how I got interested into HighRise firefighting, it was the 200 Wellesley Street fire. We had 2 firefighter maydays, firefighter near misses, and it was an 8-hour HighRise fire that never got out of the room of origin. After this fire, I started asking the question, why? Why did we struggle with this fire? Big fire department like ours, great aggressive firefighters, but why did we struggle? When I looked at the incident command structure of it, it was a flawlessly run fire. There's nothing that we done wrong, and actually we still run fires this way in this exact order. I actually went back to 1995 and I looked at the Forest Laneway fire. There's articles on that and inquest information, but it was interesting to see that they struggled the same way we did at 200 Wellesley Street. So I kept asking more questions. I just want everyone to realize that to make errors is human, and to worry about those errors is compassion, and to do something about those errors is professionalism, and that's where we like to hold ourselves as firefighters as professional firefighters. In saying that, this is the Toronto Star article on how we made our changes. It's called Fire in the Sky. It talks about the Maydays. It talks about where we were tactically and how we went about making these changes. And we're probably one of the better fire departments now in the world that is meant to deal with HighRise firefighting because of it. We certainly learned from our mistakes. If we look at some of our bigger fires that started from a 6 alarm and some of our unfortunate deaths, and we look at Wellesley Street, we look at Forest Laneway in on the park, where we had 6 people pass in both those in on the park and Forest Laneway. How can we make firefighting better? We have to learn from our history. If we look at this fire here, the same thing. What are those firefighters in the middle carrying? What is that? Well, it's a giant CO2 extinguisher, and multiple of these things were brought to this particular fire, and we really struggled. It was a year and 6 months before occupants were allowed back in the building. But how do we go about sharing this information, and how do we prevent this from happening again? The Queen's Quay fire, same thing. It was an impressive-looking fire, but we realized that now we have the proper flow and volume of water. We actually quickly put this fire out, even though it looks spectacular. We go back to our Mayday in 2018. This is another HighRise firefighting where a captain had a Mayday, and we learned from this fire that staging resources and equipment is a key if something was to go bad. And in this case, it did. And our rapid intervention team were right where they're supposed to be, pre-staged, and we were able to rescue this firefighter without incident. If we look at our 2010 fire, that was at Wellesley Street that I talked about, that was a 6 alarm, and we look at a 2019 exact same building 4th alarm, we can see that we're improving. And what we learned from these two different fires was volume of water, positive pressure isolation when it comes to preventing smoke from spreading through buildings. So we are learning, we are getting better, we are evolving. This is a 5th alarm fire in Gosford. Fire went up 9 stories on the exterior of the building and auto-exposed into other units. And again, what we learned from this fire was the advantage of large volumes of water, the ability to hit it from the exterior with smoothbore nozzles, what our reaches of streams were, and we were able to combat that fire and learn from it. This is another 5th alarm fire in Toronto as well, and it's just a very similar process of evaluating ourselves after the fact. And we know now about leapfrogging, adding to the front, the potential of coming up short, smoke migration, and again, hitting it from the outside and understanding the science behind that. We're getting better now. We're down to 3rd alarm high-rise fires. I've never been to a high-rise building that's under construction and had water, and this was the same case. We had the 15th and 16th floor on fire. We had fallen debris falling down to the podium below, and what happened here was we were able to get water in 11 minutes because of our scenario-based training and our improvised standpipes, which is very quick. 11 minutes may sound like a long time to you, but in firefighting's world, in a building this high, it's actually super quick. So we are learning, we are evolving. When I do travel the world and I go to fire stations, I ask the firefighters to tell me about their story and get this firsthand information. I can tell you that the ones that have had those bad fires, they tell me, hey, I was at that fire. I can tell you every firefighter there was aggressive. The fire just didn't want to go out. And I keep asking that question, but why? Why won't it go out? So let's look at the science, the research, and the investigation in dealing with this. I'm a big fan of Paul Grimwood. There's no secret there, but look at his book, Eurofirefighter 2, and it talks about the primary flow gradient. And we looked at how many liters per minute firefighters are capable of extinguishing, or how many gallons per minute. I added that in there as well. And we had the 6 different sizes of fire. What type of hose and nozzle package are we bringing for each one of these fires in each one of these scenarios? We also looked at how many BTUs per second, or how many gallons of water can absorb a particular amount of BTUs. We also looked at the hose line size, the tip size, gallons per minute, liters per minute, and how much BTUs can be absorbed. And if you look at that, we want to be in that 41,000 heat absorption area. Unfortunately, with that great absorption rate, we're going to experience 100 pounds of nozzle reaction, and nozzle reaction is very difficult for firefighters to handle. But that's where our target zone is. We want to be able to throw 1,000 liters per minute at the fire, 266 gallons. Science has caught up to the fire service. We know what our hose lines are flowing. We know what our tips are flowing. We know what our nozzles are flowing. We know the different tactics. And now it's time to get the word out to boots on the ground firefighters with this new science. So we use barrels in this case. So I can tell you in Toronto, we're using a 1 1/8 tip. So every 13 seconds, I'm putting a 55-gallon drum downrange. With the exact same hose and nozzle packages, if I switch to a portable monitor, then every 6 seconds, I'm putting a 55-gallon drum downrange, and that's made a difference in our firefighting because our fires go out quicker. When we took Paul Grimwood's science, we added our hose and nozzle package now. If you look at that blue hose up in the top there, we're now capable of putting that 1,000 liters per minute on the fire. That gives us a rapid fire knockdown. We're good for defensive fires. And what we like about our new hose and nozzle package, it's 65 millimeter, by the way, and 2.5-inch hose lines. If we change the appliance on the end or the nozzle, so in this case, a portable monitor, we can flow 500 gallons per minute or 528 gallons per minute when we tested it. That's doubling our output. It also doubles our reach. And this is what gives us the penetration into these fires now. And our hose and nozzle package doesn't change. We simply replace something differently on the tip, and that gives us that punch. So here is our punch. We light a room on fire, it's fully involved, it flashes over, and within 6 seconds, we're able to extinguish that fire. We need to start using reach of stream. We have a 100-foot reach of stream in this case. At 1200 degrees, that 100-foot reach of stream will go to 50 feet, but 50 feet, worst case scenario, is plenty of water reach. Our deployment, we do have a bus, but we don't use it for firefighting, but the analogy is very similar. When we pull up to a high-rise fire, regardless of your truck designation, the first 2 trucks are going in, and we're going in with 6 firefighters. We're going to lose 1 firefighter elevator control. That gives us 5. However, it's critical that we get 6 lengths of hose up there, and you're about to see why. With 6 lengths of hose, that gives me the ability to do an improvised standpipe. And with our present hose and nozzle package, that's how high we can pump water. So it actually works great. If the standpipe system fails, we know we have 30 stories worth of hose that we can do an improvised standpipe. So the science works. This is an overscripted slide, so you can take a screenshot or take a picture, but it talks about our improvised standpipe, how we go about doing it. No extra or additional equipment is needed. We can do that from the first 2 crews, and they each have the option of doing that. Each crew brings 15 stories of improvised standpipe. Now, this is still a draft copy, but what we've done is we're taking a complete failure of the building where the fire department has to do improvised standpipe. There are different types. There's actually 8 different types of improvised standpipes, and we took the friction loss calculations for all of them. So we can tell you what floors, depending on the improvised standpipe that we're performing, where we can get water to. And every building's different. So some buildings will have a beautiful well where we can stretch 30 stories. Some will be a closed well where we may only get to 11 stories. But the point of this is that we are doing the research and we are trying to troubleshoot and problem solve the future of high-rise firefighting. We also took our reach of stream. We needed to know how far we could get on the exterior of the building, which are reach of stream. So we took our average hose and nozzle package, which you see there on the bottom in blue, the 1 1/8 tip, and we know we can get 7 stories. If we go all the way up to our 230-foot tower, we know with our reach of stream there, we can get to 35 stories. Now that's reach of stream from the exterior. We have other tactics that we can obviously get higher on the exterior of the building by using the interior standpipe systems with our special nozzles and tactics. If we look at a fire attack plan, some cities call them battle plans, but we took our reach of stream and we overlaid it on our buildings. So we know at 7 stories, you can see there in blue, that's what we're getting with the 1 1/8 tip. Our 110-foot aerials, that's where we can get in the yellow. That's on the alpha side of the building. If you go around to the Charlie side, you'll notice that the parts that aren't highlighted, well, those are areas that we can't get with a 110-foot aerial. So we're lacking in reach of stream. However, we do have that 230-foot tower now, or 70-meter tower, and that particular building that I showed now has a protection because of this new appliance. Our third-in crew. This is kind of important because depending on the size of your department, you're going to go through resources quite quickly. And our third-in crew are going to be following the MISS acronym. And the MISS acronym stands for medical, IRIT, smoke control, and stretching. We're going to lose the captain to lobby. Driver's going to help with entry control, and 2 crews are bringing medical equipment up. So this is what it's going to look like, a side view of the high-rise building. We have our first and second crew up top with 5 firefighters. That third-in crew goes up with the medical, and they're 1 floor below. That crew with the medical equipment is prepared that if a firefighter goes down, they can deal with the firefighter's medical issue. Or if they find an occupant in the building, the firefighters can take the occupant to the floor below, and they can get immediate medical attention. So that's called the MISS acronym: medical, IRIT, smoke control, and also assist with stretching. As far as our hose and nozzle package go, because we're bringing the big line, we do have a weapon for all types of fires. When moving the hose, we close it. If we want the amount of liters or gallons per minute from a water can, it's a 1/4 bale. If we want to do hydraulic ventilation, overhaul, or use it as a fog nozzle, it's 1/2 bale. Or if we need that full potential of the 1,003 liters per minute or 264 gallons per minute, we're simply going to open the full potential of the nozzle. So now we have a hose and nozzle package for all sizes of fire. Ergonomics is critical when it comes to high-rise firefighting. We do have to take stairs. Our kit now is super light at 22 pounds. Our hose without water in it weighs 20 pounds. Our irons weigh 22 pounds. So on average, if we add all this stuff up, the captain's carrying 22 pounds and each firefighter is carrying 44 pounds. So we've drastically been able to reduce that. And we expect all our firefighters to rescue an average adolescent at 80 pounds. So the science kind of works. Because of this new hose and nozzle package, we've opened Pandora's box and we have 8 options now without changing the hose. We simply replace what's on the tip. So we can go in with our 1 1/8 tip flowing 1,003 liters per minute. We can switch to a Bresnan attack. We can switch to a 38 millimeter Bresnan, the floor below, a portable ground mount, the opposing tips, exterior tack. And we're also prepared to perform an improvised standpipe for catastrophic building failures. And the training is all the same. It's the same hose and nozzle package, same standpipe kit. The only thing that changes is the nozzle on the end. So here's multiple tactics being performed, and this is where exterior reaches stream can't be used. So we're using the building standpipe system or an interior improvised standpipe, and look at all the nozzles flowing. We have 2 Bresnan distributors flowing in this picture. We have the bent pipe, which is also known as a floor below nozzle, and the opposing tip nozzle. So exterior claddings, auto exposure, those type of fires, we're now prepared to tackle with them, especially if it becomes wind impacted. This is what the Bresnan attack looks like. It's the same hose and nozzle package. All we're doing is bringing up a Bresnan distributor, and that can be used for exterior cladding or a wind impacted fire where the crews can't make the push into the fire unit from the hallway. We can drop the Bresnan distributor down from the exterior. And here's one particular fire where we had to do that. We had to predict and forecast where that fire was going, and we knew from studying other high-rise fires that fire will probably be to the roof in 12 minutes. And that's exactly how long it took. We were able to get to the roof, deploy the Bresnan, lower it onto target, and extinguish the fire that was on the exterior. This is a class I teach in Pensacola Beach, Florida. And if you look at the video on the left, that is dropping the Bresnan distributor from 2 floors above the fire. The center picture shows that 60-foot reach of coverage that we have. So imagine wind blowing that water back into the apartment or using it for exterior cladding. The video on the right shows what that Bresnan distributor is hitting as far as the fire unit goes. The only thing I would suggest is I would get that Bresnan distributor up a little bit higher to get the full potential of that water spread. We also have this neat little hose and nozzle package. It's 3 nozzles in one, and depending on what we're going to do when we get up top, we can use the floor below, the Bresnan, or the opposing tip nozzle, but it's in a nice, convenient little kit like you see there. We did switch to this new hose and nozzle package because the previous one was too long. We couldn't get it into stairwells and revolving doors, but we're certainly more effective now that it breaks apart. So we can take it upstairs. This is the floor below nozzle. That's how much it flows, 90 liters per minute. It is a 350 kPa nozzle or a 50 PSI nozzle, which is fantastic for low pressures, high volume. That 1 1/8 tip that's on there is the exact same tip, 1 1/8 tip that we make entry into the fire unit. So we can hit it from the outside, we can hit it from the interior. It's the exact same reach of stream from the exterior or the interior. Very effective. And here's just a picture of it flowing here. Unfortunately, it does have 100 pounds of nozzle reaction, so it can be difficult to use. But with training, firefighters in this case, we're using that sawhorse as a precipice. In the real world, you'd be using the window frame or the balcony to take that nozzle reaction and lower it quite substantially. Here's another shot of it. It's got that 60-degree bend on it. So from the floor below, we can target the fire unit above us. So we have options to attack it from below. We have options to attack it from 2 stories above. We also have the options to flank attack it. The floor below nozzle, we'd like to change the name to the bent pipe because here is a rotary distributor on our bent pipe at a simulated residential house fire. We can put a giant sprinkler head into the attic, get off the roof, allow that to flow, continue firefighting operations. And on several incidents in our city, we've deployed the Bresnan distributor on row houses, and the fires spread to the Bresnan distributor or the rotary distributor, and the distributor was able to hold the fire at check until we could get it from interior. And we also have the straight pipe. There's a 38 millimeter Breslin or 1.5 inches, depending on where you are in the world. But we can core a hole. We can deploy the Breslin distributor. It's not just a mist. It's actually a smooth bore nozzle that spins, and we can put up the proper amount of liters per minute or gallons per minute. And this is what it looks like there spinning. Again, it's not a mist. Those are smooth bore nozzles putting out more liters per minute or gallons per minute than a traditional misting nozzle. So it's very effective, and all it needs is a 4-inch hole. That's our coring tool. It's battery powered. If you are going to purchase one, I would research a better bit and a better tool. But this was, we purchased this in its infancy. It is working, but there are better equipment out there. So you simply make the hole, insert the nozzle, and start firefighting. The opposing tip nozzle, it's fantastic. It is traditionally only used for hidden voids. We've taken it to another level. It's got 1/2-inch tips on it, so we can actually use that for exterior cladding fire. We can remove the 1/2-inch tips and expose the 15/16 tips, and we can actually use it for a flank attack in a high-rise building. Because it's an opposing tip nozzle, it takes all the nozzle reaction away. So firefighters can put this nozzle on the exterior of the building, have no nozzle reaction. They won't be fighting with it. 50% of the water will be wasted. However, the other 50% will be going on to target on the fire. So it is a fantastic nozzle. And there it is flowing. It's got 80-foot reach of stream off each side. In this particular video, it has the 1/2-inch tips. So it cuts through cellulose, pink foam insulation. It's fantastic for balloon frame construction, or for a high-rise. We can help remove those tips, flow more volume of water, and use it as a flank attack, or again, exterior cladding. So they're just an example that it has no nozzle reaction because of the opposing tips. These are a couple fires here where we used it in hidden voids. Again, 160-foot reach of stream. All I need is a small hole to be able to get the water in. We call it using smart water. It doesn't take much water if you know where to put it. And in this case, this floor had collapsed. The fire was underneath it. It was going to spread, and we're able to get at it using reach of stream, and all we needed was a small hole. The exterior smoothbore attack, no matter which fire department you are around the world, learn how to do this, understand the science behind it. We are not creating the streams that are killing these victims like we once thought. The victim needs immediate relief. Look up the UL study on surface cooling. It's fantastic, and it'll tell you why we can hit it from the exterior. We're hitting the ceiling. It's called surface cooling. It's exact same practice that we're doing when we enter from the interior of the building. Our target initially is the ceiling. We flow the full potential, and it gives occupants inside a relief. Our portable ground monitor, again, it works off the exact same hose and nozzle package, but it doubles our liters or gallons per minute. It also doubles our reach of stream. So for those hot fires or those distant type fires, we now have a battle plan for that. As far as catastrophic standpipe systems failures go, we do have I wouldn't say a solution, but we do have a plan, and we use 4 fire suppression tools. That buys us the time to get our portable calf system up top, and our portable calf system puts out 600 US gallons of finished foam. So we're using 4 fire suppression tools, our portable calf system. That portable calf system can be refilled off the standpipe system if there's still headwater left in the system from 4 floors below the fire, or we can perform an improvised standpipe and keep fueling up that calf system. That's what it would look like here. We do door control. We're going to deploy 4 fire suppression tools, and we're going to allow those to work for a minute, and then we're going to start filling the room up with calves. And we're going to try and limit the amount of smoke that spreads throughout the building. We do need a stair climber to actually pull this task off, and you can see in the stairwell, there's our portable stair climber. We're just wrapping up here, almost done, but here are some tactical options for high-rise firefighting. If you have a clear hallway, what to use. If you have a dirty hallway, what to use. If you've come up short, what to use. If you're unable to reach the fire department, you still can't reach the fire department. There's a whole bunch of different scenarios, attack options, and I also put the pictures to make it quite clear. Same thing with water supply issues. I put the scenarios, the tactics, and some pictures on what that would look like. So please help yourself to that. there's my contact information, Brent Brooks, at just HighRiseFirefighting.com. Reach out to me if I made a mistake in the presentation. Please correct me and reach out so I can correct it, because I am spreading this information around the world. And I want to thank you, Firebuyer 2023, for again having me as a guest. I enjoy doing these topics and speeches. It's a passion that I have. So thanks for including me.
Hi, Brent. It's so great to have you here back at Firebuyer Live again. And for this HighRise special, you focus on specialty nozzles. And you dedicate so much of your time traveling the world to learn and teach HighRise firefighting. Are you finding that there are more and more cities that are now struggling with high-rise fires, obviously with the rapid growth of the urban landscape?
I am, and it's funny because when I first started HighRise Firefighting, it was obviously my department. It was local. We're researching fires, and when I reached out for help and started asking questions from other fire departments close to me, they had the same problems. When I started traveling globally, it was the same questions. The firefighters were all struggling, and we see these fires in the news. We see that firefighters are struggling. But now that we know the science, it is caught up to the fire service. So now we can actually take that science, apply it to our tactics. So it's a global issue right now, but I can tell you that firefighters are the same all around the world. We have the passion. We want to get in and help people. And now we have the science to back that up. So the future of high-rise firefighting is going to get better. It's going to get better faster now that we've pieced it all together.
And that collaboration is something that is so key in fire departments, and something that we're seeing more and more of. On the news we have, international fire departments and specialist task force coming to London, for example, to teach them on wildfires, and so on and so forth. So that sharing of knowledge is really important. And you have high-rise firefighting down to a science, quite literally, if you pardon the pun. But what areas are you still looking to expand your knowledge on in that area?
We're really good at firefighting now. It would be the smoke movement, smoke containment, and smoke evacuation. If we can nail that down, add that to our science of high volume, low pressure. In our case in North America, I know other places around the world, they don't have that luxury of having the volume of water. But if we can add smoke control, evacuation as well, into that firefighting package, it's certainly going to give us the ability to build these buildings bigger, more unique, different layouts like what's happening. So I'm excited.
Well, definitely. And hopefully, obviously, as these buildings are getting smarter and smarter, along with that is also the ventilation systems that come with it, and the HVAC systems, where we can actually control that smoke better from a building management point of view, which will hopefully enable firefighters to manage that better as well. So time will tell on that front. And if fire departments who are watching today are looking to expand their equipment for high-rise firefighting, are the specialty nozzles that you spoke about in your presentation also cost efficient as well as effective types of equipment for them to invest in?
They are, and there's really nothing special about these nozzles. The fact that we've actually simplified them by making them smooth bore, that gives us that massive volume of water stream that goes down range. By adding the rotary distributor, taking nozzle reaction away from the firefighter, has given us that ability. High-tech stuff, has a different application, I think, in the fire service, but it's the meat and potatoes of the big water in our case to be able to get it down range using it smartly. And specialty nozzles has allowed us to do that and has taken the nozzle reaction away. So it actually puts it in play. And the prices of it, because they are very simple, it's certainly within budget of most fire departments.
That's really great to hear, because equipment, although is coming out technologically advancing, every day, and there are a lot of different investments that fire departments can make. but obviously budgets always play a part of that. So to know that there are solutions that are cost effective, also for departments in other areas of the world that don't have as large budgets as obviously the main fire departments that we think of. I just wanted to to finish on a slightly fun question. But what is your personal favourite nozzle to use and why?
Oh, that's a good one. I think if you would ask any of my colleagues and any of my peers, they would say it would be the rotary distributor, because we're using it for EV car fires, because we're using it for exterior cladding. We're using it for a number of different applications. But at the end of the day, my favorite nozzle would be the smoothbore 1 1/8 tip, because that is our initial attack line. And if I can get it with the initial attack line, I won't need my specialty nozzles. And I've learned over my 29 years with my city and 31 years as a firefighter that I used to think Metallica, the rock group Metallica. Mm-hmm. But now when I get on that 1 1/8 tip, that smoothbore nozzle, I switch to Mozart. And it's a nice, easy water application. Allow that reach of stream to work. That's made the big difference. So wisdom on that line has certainly led to it's a fun time to be on the nozzle and enjoy that Mozart movement.
Well, that's brilliant. And anything that we can do in prevention methods or early attack methods to prevent risk to firefighters and to assets and to buildings and victims, that's what we're here for. That's what we were fighting for and trying to grow our knowledge on. So that's a really nice way of putting it. So thank you, Brent. And as usual, I really appreciate your time and your presentation. If you would like to see Brent's previous sessions, you can find them on demand in our on-demand stream available on the platform. If you have any further questions, please reach out and connect with Brent. Thank you.
Thank you.